Hey, ladies and gentlemen, Terry here. Welcome to another daily LeetCode challenge. Today we have question 109. Today we have 1992. Find all groups of farmland. You are given a zero indexed M times N binary matrix land where a 0 represents a hectare of forest land and a 1 represents a hectare of farmland. To keep the land organized, there are designated rectangular areas of hectares that consist entirely of farmland. These rectangular areas are called groups. No two groups are adjacent, meaning farmland in one group is not directionally adjacent to another farmland in a different group. All right, well, I'm not about to read everything. Return a 2D array containing the 4 length arrays described above for each group of farmland in land. If there are no groups of farmland, return an empty array. You may return the answer in any order. Okay, so basically what the question is saying is that we get a matrix like this, and there are a box of farmland, which are represented by 1. So you see there is a box like this and a box like this, and they are always diagonally adjacent. They are never horizontally or vertically adjacent. If you see, like here, there's only 1. And here there's 1 and 2, and there can't be farmland here or here. Oh, okay. So groups of farmland are rectangular in shape. Okay, so we just have to return the starting coordinate and the ending coordinate of all farmlands, right? So we have this farmland. We return 0, 0, and it ends in 0, 0. And the second one starts in 1, 1, so it starts in this square and it ends in 2, 2, ends in this square. So in this one, the farmland, this big box, starts in 0, 0, and it ends in 1, 1. So it returns 0, 0, 1, 1. Okay, I'm back. I'm actually in the laundry room right now recording this because it's so loud with my roommates. Anyways, how can we solve this problem? So my intuition tells me we can use a DFS solution similar to number of island question, and we will just go left to right, top to bottom, and we will run DFS on every one we encounter, and then the DFS will also run a check to see if it's the ending box, and if it is, it will complete the answer for that specific farmland. So what I mean is our main function will run top to bottom, left to right. So it'll encounter a 1 like this one at 0, 0, and the main function will append 0, 0, the first part of the answer, to the output array, right? And then the DFS function will change all the ones to hashtags so we don't encounter the same boxes again, and it will also check if that current cell is the ending corner cell for that farmland, and if it is, it will add its coordinates to the answer for that farmland. So let's start it all over again. So our main function will encounter a 1. It will say, okay, we're starting a farmland. It adds 0, 0 to the output array, and then it'll run DFS, and that DFS will check if it is the ending box, and in this case it is. So it will add its coordinates to the answer for that farmland, which is 0, 0, and it will complete this box. And it would also change it to a hashtag so our main function doesn't use the same cells again. So our algorithm will go through and it will encounter 1, 1 as a 1. So it will add it to the beginning of the output array, and then it will run DFS. So this changes into a hashtag. DFS will call DFS on its neighbors. This changed into a hashtag, same as this. And these are not the corner cells, so it will keep going. And then it will go to this one, and it's going to change it to a hashtag, and it's going to realize that this is the ending cell for this farmland. So it will add its chords, which is 2 and 2, to the output answer. And that's how we are going to solve this problem. And of course, in this one, it's never going to add anything to the output answer. And this one, it's going to start here, and it's going to end here, and it's going to know. Okay, let's code it up. Oh, sorry, I forgot to put the comments here, but basically our main function will run DFS on the matrix left to right, top to bottom. DFS will change cells to hashtags, change one cells to hashtags, and append itself to the answer array if certain conditions are met. And those conditions are: it is the starting cell for a farmland, and 2, it is the ending cell for a farmland. And that's basically what the question is asking us to do. Add the start chords, add the ending chords, and return as an answer. So runtime is O of m, n times m, because there are n times m amount of elements that we have to check. And the space is O of 1, because we're not using any extra space except for the output answer array, but that doesn't count as extra space. So let's code our solution. Rows and columns are length of grid or land, length of land 0. In columns, so we're iterating through each cell, top to bottom, left to right. If land x, I have to call range on these integer values. So if the current grid is a 1, then we have to run DFS on xy, and we have to also add the starting coordinates xy to our answer, like that. So answer is a blank array for now, and then at the end we're returning answer. So we're appending xy, the starting chords, to our output answer, and then we have to run DFS. So let's code DFS xy. So we need to do some checks. So if x, y are out of bounds, so if x is less than 0 or y is less than 0, or x or y are greater than rows and columns respectively, then we are going to just return nothing. So if it's out of bounds, we will gracefully exit, and if x and y are not 1 cells, then we will also exit, because our DFS function is only for 1 cells, for farmland cells, and we're not going to use this function for anything else. So we've verified our chord is a farmland cell. We will change it to a hashtag. And the hashtag is just a placeholder to mark the cells that we've seen it before. So we've seen this, and now we have to check if it's the ending cell. So how can we check if it's the ending cell? Well, if right and bottom are out of bounds cells or 0 cells, then we know it's the ending cell. So for example, in here, its right is a 0 and its bottom is a 0. So we know this is the ending cell. And for this one, its right is out of bounds and its bottom is out of bounds. So we know this is a 0 cell, ending cell as well. So if x plus 1 is So if land x plus 1 y is equal to 0, or and land x y plus 1 is equal to 0, or it's out of bounds, so if y plus 1 is greater than or equal to columns, then it's out of bounds. So either or could work. And same here. So the right has to either be a 0 or out of bounds, and the bottom has to either be out of bounds or a 0. So if this condition is met, then we know we're at an ending cell. So answer -1 dot extend x, y. So we're adding our current coordinates to the output answer. So we're adding 0, 0 here. And then after we do that, we can just return, right? We just finished our DFS. Oh, and then we have to call our neighbors. So if this is the ending cell, we could just return. If not, we can call DFS on our neighbors recursively. So neighbors equals 0, 1, 0, -1, 1, 0, -1, 0 for nx and y, neighbor x, neighbor y in neighbors DFS x plus nx. Oops. DFS of nx plus x and ny plus y. That's it, I think. Okay, accepted. I'm going to submit. Let's see. Let's hope that I got it right the first time. Yes, let's go. All right, that is the solution for find all groups of farmland. Thank you, and see you in the next one. Peace out.